friends after a long time. So the puja holidays, and also you know that our state was totally halt almost due to death of a legendary singer, Mr. Zubin Garg, for which our state was mourning for the last 10-15 days. So okay, now we are going to start a new module, that is linear algebra. Now remember our school days. In school curriculum we had the linear algebra, where we had to solve the simultaneous equations. Suppose 2 by 2, say 2 equations, 2 unknowns, or 3 equations, 3 unknowns, like that, by hand. So if the number of equations and number of variables were higher, then we have to take the help of a matrices. And for bigger one, sometimes the planning commission will find that they use the software to settle such kind of equations. Anyway, we'll discuss here the basics of linear algebra, that means the simultaneous equations and how to solve them in matrix. So it is called linear because the maximum power of the variable is 1. If power is higher than 1, then it becomes non-linear. Okay? So suppose this is the system a11 x1 plus a1 to x2 plus so on, a1 and xn is equal to b1. That means it is an equation. So a1 is a coefficient of x1, the variable x1, because when you will illustrate, it will start with a value, with a number. So a1 on x1 plus a1 to x2, so on, to b1. Then next is a21, that means it is the coefficient of variable 1 in second equation. Similarly, a coefficient of variable 2 in second equation, like that. So there are m number of equations and n number of variables. Okay, so this is the solution. We call it the solution factor. Now, if we separate out the coefficients in matrix form, so matrix A, coefficient matrix A is equal to all those coefficients, A11, A12, so on up to A1n, A21, A22, so on up to A2n, okay, AM1, AM2, so on to AMN. So in short, this can be written as matrix Aij. So when we will expand I, so 1 to m, and j is equal to 1 to n, then it becomes this. So the order of the matrix will be, we have m number of rows and n number of columns. Order is m by n. I stands for rows and j stands for column. Then what are the variables? This variable matrix is x1, x2, so on up to xn. Then B matrix, solution vector, because these are known. So this equation is equal to this much, this equation is equal to this much, like that. So when you will illustrate, it will be some figures. So it will be, we call it a solution factor. Solution factor. So it can be expressed as, in matrix form, AX is equal to B. The whole thing, the whole equation system can be expressed as AX is equal to B. So Now a matrix is defined as a rectangular array of elements arranged in rows or in columns. So a rectangular array of elements which are arranged in rows or in columns. So it has mn elements. So in this, it is a general form. It has mn elements and arranged in m rows and n columns. Order is m by n. When m is equal to n, the number of rows is equal to number of columns. So it becomes a square matrix. Okay. Then equality of two matrices. That suppose there are two matrices A and B. In short, you can write that matrix Aij is equal to matrix Bij if the order is same. So it is an m by n matrix, and this is also an m by n matrix. Then we say that Aij is equal to Bij for its pair of subscript I and j. So all these pairs, Aij and Bij pairs. Aij, suppose 1A11 is equal to B11. Elements in first row, first column, and elements in first row, first column of matrix B. So if they are equal, element by element, then we say the matrices are equal. Okay, next we'll discuss the equality and types of matrices. Okay, thank you. Go on watching.